Hi guys, welcome back to my channel Leela Web Dev. Today we will be diving into this video into a coding problem. So let's try to see about one of the coding problem. Let's say that the problem is how to calculate the sum of all numbers from 1 to some number. Let's say n. For example, if n is 3 means then we need to calculate if n is equal to 3 means then we need to calculate something like 1 plus 2 plus 3. If n is 5 means we need to calculate the sum of all the numbers 1 plus 2, 3, 2 plus 3 plus 4 plus 5. So this is the problem. So this is the thing which we need to calculate. So we will look at two different ways to solve this one. And also we will compare both the solutions also and figure out which one is better. So let's try to see about this one. So and also we'll see why that one is better and isn't always simple and how we can measure the code performance also. We'll see about this one. Let's get started about this. So now our goal is to write a function that adds all the numbers from 1 to n. If n is 3 means then the answer will be something like 1 plus 2 plus 3. That is nothing but it should be the answer should be 6. So like this. So if n is 6 means then it should be something like 1 plus 2 plus 3 plus 4 plus 5 plus 6 should be answer. It should be something around 21. So we are going to explore two solutions to this problem. One that is straightforward, so which you will be getting into your mind, and another one is little bit tricky but it is super fast. So then also we will compare them to see which one wins. So let's start with the first solution, that is nothing but the loop solution. So whatever the n value we are getting it, we will try to get the loop solution. So here I will be giving add.js file. So just here, okay. So this one is most common thing. So we'll create a variable called total and we'll set it to 0 and we will use a for loop to add each number from 1 to n one at a time and we'll get the output. So here is what the code looks like in the JavaScript. So here function add and I will try to send the number, and here I will have a value something like let total is equal to 0, and here I will try to loop over something like this from I is equal to uh, let's say that here I should be having 1 less than or equal to n. Okay, and here I will be having the total and I will return the total. That's it. This is a simple thing. Okay, so now, so what I will be trying to use here, you can, if you want, you can execute this one in the browser, or if you want, you can execute this in the Node.js, anywhere, wherever you want it, you can do it. So now if I run this add of n, okay, let's try to see here. So I will do the console.log add of 6. I will try to give add of 6. So what could be the output I will be getting it here? So I will be getting it 21. So let's try to go it here and I will do node add.js. So I am getting it as a 21. So perfect. So now whenever I am trying to give it as an add of 3 means I'll get 6. And for a big number something like 100, if I try to give add.js and if I try to change it to 100 and here if I try to run it, so I am getting 50-50. Okay, it works perfectly. So the solution is also, now it is very easy, but you need to understand that easy is the best solution. So let's look at the second approach also. So now the second approach is, so we have a mathematical formula to calculate the total of n numbers. Okay, so that is lot shorter and less obvious. Instead of a loop, it uses a mathematical formula, that is nothing but n into n plus 1 divided by 2. So let's try to use the same thing. So here I will use add performance.js file, and here you will be having a function, same thing, add of n, and here instead of having the loop I will try to do return n into, see here you will be able to get n into n plus 1 by 2, and here I will do console.log add of 100. Now if I try to do this add performance.js file, so you'll be able to see the same output we are able to get it. Okay, so it is equal to 6, you will try to see. So it is trying to do 6 into 6 plus 1 divided by 2. That means it will calculate 6 plus 1, that is nothing but 6 into 7 by 2. 6 into 7, it will be 42 divided by 2, then it is 21. The same result as the first solution. So now for n is equal to 3, you will be able to get 3 into 4 by 2. So that is nothing but 3/4. So here you will be getting it as 6. 12 by 6, 12 by 2, it will be getting it as 6. So you might be wondering where this formula has been come from. It's a mathematical trick for summing of the numbers, but I will not go dive into this one today. So if you want to know about this one, so you can search it in the Google or something like that, so you can find the resources, so you will be able to see. For now, let's focus on comparing these two solutions. So which one is better? So comparing the solutions. So how you can compare the solution? Both solutions give the same result only. So if we try to give this one node add.js, it will give the same solution, and the second one also is giving the same solution only. But which one is better? So here here what I want to say is better depends on what you are caring about. So which scenarios you are caring about, so that is what better means. So here are some things which we need to consider. A code is better. One is the speed. How much fast is your code running in? That is nothing but seconds or milliseconds. And the memory. How much memory does it use? How many variables have been created here? And another one is readability. Is the code is easy to understand or not? And another one, last one is the shorter code better or not? Try to see. So some people love the short code, but I think speed and memory are often important, especially for the big projects. However, readable code is also crucial so others can understand it. But the tricky part is faster code sometimes can sometimes be less readable. Balancing these is an art of writing the good code. So for now in this video, let's focus on the speed. So now let's try to test the speed in with the timing functions. So I will be using the performance.now. So that is the browser function or the JavaScript function which is available. So let's test us how many milliseconds have been passed. So here what I will be trying to do it is, so here I will be writing in such a way that here I will be writing constant t1 is equal to performance.now. And after finishing this one, so I will be writing performance, and here I will be taking it as a t2 minus t1, that is nothing but this. So here if you want to write it, so here you can write in such a way that milliseconds. If you want to get it in the seconds means, so here you can write it by 1000. Then you will get the seconds. So that is the thing. So now let's try to do it for our performance thing also. So I will be giving here, instead of having this one, I will write 1 billion. Here I will be writing it as in 1 billion. Okay. Let's try to check the node add.js file. So if I try to check the add.js file, let's see, it is taking too much time to execute this code. So let's see that how many seconds it will give you. It is taking too much time. Let's see. So now it will be taking around let's see. So now try to decrease two zeros so that we can able to get it easy. How much time it is taking. So if I try it, so here it has taken around 0.697 something seconds. Okay. So if I write another 0, let's see, and if I write it node.js file, so it would be taking around 1.2. Okay, it was going too much. So it was taking, so 6 seconds, it has taken 6 seconds for this one to give me the output of something around like this. Okay. Now the same code which we will be trying to do it is, so we will try to see the second solution with the same thing. So here also we will try to write it the same thing. I will try to, I think, okay, I will copy this one, paste it. Okay, and let's try to check this one, node add performance.js file. If I try to read, instantly we got the output. Okay, instantly we got the output, but this time it has taken this, it is showing different and this one is showing different. The memory. So let's try to clear it off. Node add.js file. So much time it is taking. So it was taking around 5 lakh something, 671 something like that. And here also you'll try to remove 0, and we'll take it something like node add performance.js file. and try to give it a something maybe. Okay, node add performance like this, and node add.js file is also coming same thing, maybe big number or something like that. So now here you should be able to understand one thing. Okay, so now you will be able to understand. So if I am taking 1 billion times or something like that, so it is getting uh, too much time. The first one, this one finishes. So now here you will be able to see the problems with the timing here. So we are able to see that the second one is performing better. So timing code isn't like this perfect, right? So why? Because sometimes if I try to execute the same thing, so for example, let's say that I will add two zeros here, and also I will add two zeros here. Okay, and let me clear out this one. So let's try to add this one. So here it is taking every time I execute this one. So the timing is not consistent. So it's some in my same machine, the machine which I was using this one, the same code is running differently when I'm executing different. So the same thing, if you run differently in different computers also, it will run like this only. A faster computer might make the loop method seem slow, but the gap between the two solutions could vary. So if I try to do this one add performance thing, so this one will be very fast. Okay, so here 0.00096 only it is taking. So now we are able to see that the second one is performing more. And even in my computer, if you try to see, the same code gives slightly different times each run. So it is not super. And here, if both solutions are super fast, our timing tools may not be accurate enough to tell which is better. So for example, let's say that this one is also, the first solution is also too much fast, means we cannot able to recognize which one is faster. So timing is useful, but it is something like not correct way to use it. Imagine if your code takes an hour to run and you are comparing it to one that takes 4 hours. So you don't need to wait too much long to test it, right? And also, how do we describe the difference? Do we say one is 50% faster? It is not clear. Wouldn't be great if you could compare code without running it? So we cannot. So this is where big O notation comes in. So it is a way to describe how efficient code is without running it. So we can look at the code and figure out which one is faster and uses the less memory just by analyzing it. It is like giving each solution a score we can compare. So that is where the big O notation comes here. So I would dive it into big O now in this video. So that is for the next video. But trust me, it's going to make comparing code so much easier. No more waiting for the test or dealing with the unreliable timing. So executing the code and waiting for so much timing or something like that. So there is no wait. There is no need reason to wait for this one. So that's it guys about this one. So we have seen two ways to sum numbers from 1 to n, a loop that is easy to understand and a formula that is super fast. We have seen it, and we have seen the timing which showed the formula is quicker but the timing is not perfect. Timing means the time which we are trying to do it. Why? Because every time I run it is giving different timings. So next video we will try to explore the big O notation to compare these two codes like a pro. So if you enjoyed this video, hit the like button, subscribe and ring the bell for more coding tips. And also drop a comments if you have any questions or share any of the solutions or something like that. See you in the next video. Thank you.